Hi everyone, and welcome to Chemistry with Wikipedia. Today I will be doing a tutorial on electron configuration. So this will be twofold. The first thing I'm going to do is go over how to do the front part of the electron configuration worksheet. So here I have the first problem, phosphorus, and I'm going to show you how to fill in these lines. Then I'm going to go through and I'm going to explain how to do each of these things individually. So we'll talk about how to complete the orbital spin diagram, how to do the electron configuration, and how to do the condensed electron configuration. Okay, when we are looking at this worksheet here, the first thing I need to do is figure out the number of electrons. So I will go to the periodic table. I'm going to find phosphorus. Phosphorus is right here. It is number 15, which means that it has 15 protons, and because it's neutral, it also has 15 electrons. So where it says electrons here, I'm going to put 15. So this first space here is for the orbital diagram. So the first thing we have to do is we separate each of our orbitals into sublevels. So I'm going to label each of these like we did in class. So we did 1s, 2s, and then because p has 3 orbitals, we have 2p, 3s, 3p, and so on and so forth. All right. So I label all of these, and then I put in my electrons as arrows, just like we did in class. I do an up arrow, down arrow, move to the next, up arrow, down arrow, move to the next. So 4, 5, 6, 7, and then 8, 9, 10. And I go to the next one, 11, 12, and I go to the next one here, 13, 14, 15. All right, so that is my orbital diagram. For many of these, you're going to have to go past the 3p, so you'll just use the fill-in diagram that we used in class. If you're not sure what that is, keep watching the video and I'll go over that as well. Okay, so we filled in the first line. The second line is the electron configuration. So this is where I don't need to do the arrows. I just write the sublevel, and then I write the number of electrons in that sublevel. So 1s has 2, 2s has 2, 2p has 6, 3s has 2, and 3p has 3. So remember that each of these exponents has to add up to the total number of electrons. 2, 4, 10, 12, 13, 14, 15. All right, and then for the last line, I'm going to do the condensed electron configuration. So for this, I'm going to go back to my periodic table. So on my periodic table, I found phosphorus. So what I'm going to do is I'm going to go to the previous line all the way to the end to the noble gas that is above phosphorus. So neon is above phosphorus. So I'm going to start with writing the symbol for neon in brackets. So I'll put neon in brackets. And then I'm going to start with the energy level that is immediately above that. So we'll go back to our periodic table. All right, so if we look at phosphorus here, we'll go past neon to the next level so that the level that phosphorus is actually on, which is level 3. All right, so that means that I start with 3, and the first sublevel is always going to be S. All right, so if we go back to the periodic table, we see here that neon has a total of 10 electrons. So that means that when I start, I'm starting with 10 electrons. All right, so I've got 10 already. And so then I find 3s on my diagram that gives me the energy order, and then I just fill in starting from 3s. So 3s2, that gives me 12, and then 3p3 will give me 15. All right, so for each of the problems that are on the front of that worksheet, we're going to first figure out the number of electrons, we're going to fill in the orbital diagram, do the electron configuration, and then do the condensed electron configuration. Okay, so that's how we do the worksheet. So now if you are having trouble figuring out what it is that I have done here, then let's continue on into how do we do electron configuration. If you've got what you needed, you don't need to watch the rest of the video. Okay, so the orbital diagram. So for our orbital diagram, we have to fill in what sublevel is each of these lines, because each of our lines represents an orbital. So the order that I go in is going to be given to me by this energy diagram here. So I always start with one s, and then I mark off the number of orbitals that the s has. So if we remember, s always has one orbital, p always has 3 orbitals, d always has 5 orbitals, and f always has 7 orbitals. So s only ever gets 1 line, p only gets 3 lines, d gets 5 lines, and f gets 7 lines. All right, so since this is s, I only need 1 line, so I'm just going to make a little barrier here. All right, next I go to 2s, and since 2s is also still the s, I only need 1 orbital. And then from 2s, I come up here to 2p. So p has 3 orbitals. The number in front doesn't tell us anything about the number of orbitals or the number of electrons. That number just represents the distance away from the nucleus. So this p sublevel is on the second energy level. But because it's p, it still has 3 orbitals. So I go 1, 2, 3. That's my divider. And all of this is 2p. From then, I come down here to 3s. S is 1 orbital, so I need 1 line. Then I come up to the next diagonal, which is 3p. P has 3 orbitals, 1, 2, 3. So all of those are 3p. Then I go to 4s. S is 1 orbital. So this is just 1. And then I come all the way back up here to 3d. D is 5 orbitals, so it gets 5 lines. 1, 2, 3, 4, 5. All right. On the worksheet, there are more lines, so you have to keep going. So you would go to 4p, which would have 3 lines. Then you'd go to 5s, which would have 1 line. Then you'd go to 4d, which would again have 5 lines, and so on and so forth. So however many lines you have, that's how far you keep going. And each of the sublevels has this many lines, regardless of the number that is in front of the letter. So once we have all of these labeled, they stay the same for every single problem. So it's always going to go in this order. They're always going to be this many orbitals for each of my sublevels. That information never changes. So you can go through and you can just label all of them ahead of time. Once they're all labeled, then we can go in and we can complete our arrows to indicate how many electrons we have. All right, so I have already gone through and I have labeled all of my sublevels and assigned orbitals to each of them. So I'm going to go through and do all of the practice problems that are on the electron configuration handout. So we'll start with nitrogen. We'll go to the periodic table to see how many electrons nitrogen has. So nitrogen is here, and it's got atomic number 7, so it has 7 electrons. All right, so we're going to fill in the electrons on our diagram that we have created here. Each electron is going to be an arrow. On each line, I can fit a maximum of 2 electrons. When I put 2 electrons on a line, one electron has to be facing up and the other one has to be facing down. They cannot be going in the same direction. All right, so I start with the S sublevel. So I go 1 up, and then there's only 1 orbital for S, so I go 1 up, 1 down. And I have used 2 electrons. Then I go to the 2s, which also only has 1 orbital, 1 line. So I go 1 up, 1 down, and now I've used 4 electrons. So nitrogen has 7 electrons, so I'm going to fill in the last 3 electrons in the 2p. The p has 3 orbitals, so anytime a sublevel has more than 1 line, I have to put an electron on each line before I can go back and add that second one. So I'm going to go 5, 6, and 7. So I've run out of electrons, so I don't need to go back and add another one here. If I had 8, then I would come back to the first P line and put a down arrow next to the first up arrow. Since I only have 7 electrons, I don't need to do that because I don't need any more electrons. Let's continue to the next one. We'll do cobalt. Cobalt on our periodic table is number 27, so we have 27 electrons. So we'll do the same thing. 1s only has one orbital, so I go up and down, and it gives me 2. 2s only has one orbital, so I go up and down, that gives me 4. P has 3 orbitals, so I go up, 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 down, down, down. So I go 5 up, 6 is up, 7 is up, 8 is down, 9 is down, 10 is down. And I still need more electrons, so I keep going. Next one is 3s. There's only one line, one orbital, so I put 1 up, 1 down. Now I have 12. Now I go to P. There's 3 orbitals here again, so I'm going to fill in 1 going up in each one, and then go back and do 1 going down. So I'm going to go 12, 13 is up, 14 is up, 15 is up. Then I'll go 16 is down, 17 is down, 18 is down. I still need more electrons, so I go to 4s. It's only one line, so I go 1 up, 1 down, and that gives me 20. All right, so I'm getting closer. I need 27. So here I have D, which has 5 orbitals, so I put 1 going up in each of the 5 before I come back down again. So 21 will be up, 22 is up, 23 is up, 24 is up, 25 is up. Now I go back to the beginning. 26 is down, 27 is down. Hooray and huzzah. All right, next we have sulfur. Sulfur is number 16 on the periodic table, so I have 16 electrons. Same as before, start with 1s, 1 up, 1 down, gives me 2, 1 up, 1 down, gives me 4, 5 is up, 6 is up, 7 is up, 8 is down, 9 is down, 10 is down. Keep going, 11 is up, 12 is down, and then we have a P sublevel here, so we put 1 in each. 13 is up, 14 is up, 15 is up, and then 16 we have to come back down again. All right, let's do one more. Calcium. Calcium is number 20, so we have 20 electrons. Start with 1s, 1 up, 1 down, gives me 2. 1 up, 1 down, gives me 4. 5 is up, 6 is up, 7 is up, 8 is down, 9 is down, 10 is down. 11 is up, 12 is down, 13 is up, 14 is up, 15 is up, come back, 16 is down, 17 is down, 18 is down, 19 is up, and 20 is down. And I'm done. Hooray and huzzah. Okay, so this is the orbital diagram. This is how we draw our electrons and we show their exact locations. This becomes very tedious when we have elements that have a lot of electrons. So instead of doing this for every single element, we do electron configuration. So the electron configuration, we start with our energy level, and then we put our sublevel. So this is just like what we did for the orbital diagram, but instead of drawing arrows, we write the total number of electrons that are in that sublevel as an exponent. So S will have a maximum of 2, P will have a maximum of 6, D will have a maximum of 10, and F will have a maximum of 14. All right, so that means that I can put up to 2 electrons in S, up to 6 in P, up to 10 in D, and up to 14 in F. So that doesn't mean I have to put all 10 electrons in the D. It means that D can be anywhere from 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 10. As many as we need. All right, so let's do some examples here. All right, so nitrogen, we found the number of electrons of nitrogen before to be 7. So I start with 1s, and I put 2 electrons max here. These numbers here, these exponents, represent the maximum number that can go in each sublevel. So that's kind of already there for you, so you don't have to remember. From 1s, I go to 2s, which can hold 2 electrons, so that's a total of 4. And then from 2s, I come to the top to go diagonal, and I get to 2p. I have 4, I need 7, so that is going to be 3 here. So 2 plus 2 plus 3 is equal to 7. So this is my electron configuration. No arrows needed. Next up, we have potassium. If we go to our periodic table, we'll find that potassium is number 19. So it has 19 electrons. So again, I start with 1s, 2, and then I go to 2s, 2, and that gives me 4. And then I come up here to 2p6, so 4 plus 6 is 10. And then I come down to 3s2, so 10 and 2 is 12. And then I come up here to 3p. 3p is 6, so 6 plus 12 is 18, so I can keep going. And then the last one would be 4s, and I only need one more, so I put a 1 here. These values are not exponents, even though they look like it. They are superscripts that represent the number of electrons in each sublevel. So if you have 1, you still have to put that 1 there. This is not like algebra where x to the 1 is just x. This is not saying we have s to the 1. It's saying we have 1 electron in the s sublevel. All right, let's do another one. Here we have silver. Silver is Ag. It has 47 electrons. So we'll start here. We'll go 1s2, and then 2s2 gives me 4. And then we'll go 2p6, which gives me 10. We'll go 3s2, which gives me 12. And then we'll go to 3p6, which is 18. And then we'll go to 4s2, which is 20. And then we'll go to 3d10, which is 30. And then we'll go to 4p6, which is 36. And then we'll go to 5s2, which is 38. And then I come up here and I go 4d. 10 would be 48, which is too many, so I need 1 less, and that's going to be 9. So I have 49. If you run out of space going all in one line, then you can just put it underneath here, and that's fine. So this is going to be our full configuration here. All right, let's do one more of these. Cerium. Cerium is number 58. So again, I'm going to do this down here because I know I'm going to run out of room. So I'm going to do 1s2, 2s2 gives me 4, 2p6 gives me 10, come down, 3s2 gives me 12, come up, 3p6, 18, 4s2 is 20, 3d10 is 30, 4p6 is 36, 5s2 is 38, 4d10 is 48, 5p6 is 54, 6s2 is 56, and then I need 2 more. So 4f14 is not 14, 56, so I only need 2. So that's going to be 4f2. And that takes me to 58. All right, so this is easier than drawing 58 arrows, but it still becomes very tedious because every time we start, we're doing the same thing essentially for like the first 5 or 6. It's always 1s2, 2s2, 2p6, 3s2, 3p6, and so on and so forth. So to avoid having to start with 1 every single time, we can do condensed electron configuration. So this is the last one. So for here, what we do is we pick the noble gas that is directly above our element, and we start with the noble gas in brackets, and then we continue on to the next level from there. So when we start with the noble gas, we're starting with the number of electrons that that noble gas has already. So we're not starting with 0, we're already starting with some value, so we don't have to do as much as we did before. All right, so let's look at an example here. So if we look at germanium, germanium is number 32 here. So there's 32 electrons. All right, so for germanium, I'm going to go up and all the way over to the end. So our noble gases are all at the end of an energy level, which means that they are the last electron on one energy level. So the next electron will start a brand new energy level. All right, so we start with argon. So we will put that in brackets here. And then argon already has 18 electrons. So I'm already starting with 18. So from 18, I can just continue forward. The question is, where do I go? What number do I start with? So if I take germanium and I go all the way to the end here, germanium is on energy level 4. So I put a 4 there. And then I always start with S. So I'm going to come down here to my chart and I'm going to find 4S, which is over here. We're always going to start with one of the S's, so we'll always start at the bottom of a diagonal. So we have 2, so this will be 20. And then we'll come up to 3D10, which will be 30. And then we'll go to 4P, and I only need 2 to get to 32. So now, instead of writing out 1s2, 2s2, 2p6, 3s2, 3p6. We just start with 4s2. Okay, let's do another one. Niobium. Niobium is here, number 41. So it has 41 electrons. So I'm going to go up and all the way over to krypton. So I start here with Kr, and then the number I'm going to use is going to be the number that niobium is on. So niobium is on level 5. So I start with 5s. Krypton has 36 electrons, so we need to know that. So we're going to go from 36 to 41. So if we start with 5s, 5s has a 2 maximum, so that gets me to 38. Then I need to get to 41, so I'm at 4d. So 38, 39, 40, 41, so I need 3 electrons here. Hooray and huzzah. All right, let's look at another one. Radon. Radon here is number 86. So radon is a noble gas, but we can't just use an element as its own electron configuration. Like I can't just put radon in brackets and be done with it. I still have to go up a level. So if I go up a level, my noble gas is xenon. So I have 86 electrons. My noble gas is xenon, which has 54 electrons. All right. So radon is on level 6, so I start with 6s. So I'm going to do 6s2, 54, that gives me 56. And then I'm going to come up here to 4f14. This is the first time we've used an F. 56 plus 14 is 70. And once we get to these larger numbers, if you need to use a calculator, use a calculator. That's fine. All right, and then from 4f, we go 5d. So 5d is 10, so that gives me 80. And then I go to 6p, and I need how many? 86, so I need all 6 of those. Okay, let's do one more. Thorium. All right, so thorium is down here. Okay, thorium is number 90. It's got 90 electrons. All right, so if I go up a level and all the way to the end, there's no noble gas here. All the noble gases are over here. So this is not a noble gas here, number 70. So I look here. Thorium is on level 7, so if I go up a level, I'm on level 6. So I go all the way across level 6 to radon, which is number 86. All right, so everything in level 7 will always start with radon, and everything in level 6 will always go up to xenon. Okay, so we've got 86 for radon, and we need to get to 90. So thorium here, thorium itself is on level 7. So we'll start with 7. So we'll start with 7s2. That gets me to 88. And I only need 2 more. So the next one here is going to be 5f. And I only need 90. So I'm just going to do 5f2. All right, so that is orbital spin diagrams, electron configuration, and condensed electron configuration. This has been another episode of Chemistry with Wikipedia, tutorial edition. I hope you learned something, and until next time, keep on chemin'.